Alright, time for DraftPhysics.com, debatephysics.com also, video presentation. Just as a little bit of personal news, I found out I have shingles now too. So it started with a backache, and I guess that was causing enough stress to cause shingles. And it's in the same area, hip, back, and so it's really unlucky. So that happens. It's you have to just get lucky in life. So the lucky part is, well, anyway, the unlucky part is, getting both at the same time. So anyway, so at least I'm getting some sleep now, so it's not as bad. But anyway, not a great couple of weeks. So, I just thought I would go over some of the experiments. I mean, nobody really wants to talk the theory of physics, the theory of collecting energy, how you do it in ways that aren't corrupt. They're not going to give you accurate answers. So this was a problem that came up. It's what Joule is famous for. That's why the Joule is named after him, because he made an effort to try to do that. Now, I don't think it was a perfect effort, and I don't think he thought it was a perfect effort either. But it's so it's difficult. It's difficult to come up with some mechanism to extract energy from a system, because basically the rule sort of is to do it, you need to kind of convert the energy into its most elemental form, some kind of heat, radiation even. Radiant heat, and it's just not that easy to do. So anyway, so in that line we've been doing this arguing about the nature of energy, and really until we can measure it, it's kind of hard to argue about which theory is correct until you can find some good way to measure the actual energy something contains or possesses, the capacity it has to, as I put it, just move mass. I mean, that's all energy is the movement of a mass, and you're really just trying to measure how much capacity to move mass something had or has. So a simple experiment I thought seemed reasonable was the idea of just dropping, something that, just to resolve this one way or the other, because it's really just about a mass and conversion. So you can't really take the energy in something that weighs a certain mass, one mass, and put it into something that weighs twice as much, or vice versa, in any simple way. It won't work in a Newton's cradle. It won't work in a crash, because the velocities aren't going to match, and they can't exchange the currency, so to speak. This thing can't exchange its velocity with this thing, because the velocities need to be different, and vice versa. So anyway, so the experiment where you just drop something heavy, a 2 mass, and then you drop a 1 mass from 4 times the height, then you're showing the kinetic energy duality problem with momentum, because the 2 mass at 1 velocity, so 2 mass, 1 velocity, and over here you have the 2 velocity and the 1 mass. So you can understand that by theory there's 2 kinetic energies here, there's only 1 kinetic energy here, and momentum says they're even. And so this should be kind of an easy way to decide one way or the other what theory is correct, because it really can't both be correct. One of them gets conserved and one of them gets destroyed. So Ian Gosling did a version of this where he just dropped weights on clay. Now, he didn't video that experiment because it didn't come out his way. And that's the simple truth. He would have videoed it if it came out his way. It didn't come out the way he wanted it to come out. Made a video the next day pointing out how, gee, there must be something wrong because it didn't come out our way. And even though I've mentioned it now, a couple of dozen times in the last couple of months, I can't provoke him into actually doing the experiment and showing us all what he saw, and allow us the opportunity to figure out why, okay, it did show that momentum is conserved and kinetic energy is not. The kinetic energy doesn't work. There's no sign of the extra to kinetic energies here. It's not pushing the clay, it's not compressing it more, and it should be by the kinetic energy theory. So simple enough experiment. Nobody else has done it on planet Earth, and so we're stuck with a sort of an ambiguous answer. He did a second version of the experiment that I didn't find very credible, where he dropped them and measured the dropping impact on a spring, but he had a little measuring device that basically went the speed that the thing was falling, and there was no guarantee that the measuring device didn't have its own momentum and that it wouldn't measure correctly. And so he got the results he wanted, or something closer to his results, using that experiment, but he still didn't have any good explanation for why the clay experiments didn't come out his way. Alright, so then there's been a series of lever experiments, and it got complicated, okay, because we didn't have an ideal lever. The idea that the lever consumes no energy is a real problem. So you have this basic theory that you could put the one mass two distances, okay, and put the two mass at two distances, and that whatever energy you put in, whether you put the energy in this way or put the energy in this way, that you would see the same result, which is the momentum would be conserved or the kinetic energy is conserved. And so in doing the experiments, they, in this case of putting the energy in this side and having this pop out, that it pops out with something other than, okay, 2x. It's not exactly 1.4, but you get numbers closer to this 1.4 number. Now, I pointed out that obviously the heavier the lever, the bigger this is a problem, because you have to consume a portion of the energy to actually move the lever. So you're not going to be able to get the energy into this object because a big hunk of it's going to have to get consumed by the lever. So the 2-to-1 numbers aren't going to work. Even if you have a 2 mass here, you're not going to get the right answer. You're not going to conserve 100% of the momentum. And it gets even worse the further for the lighter mass, because the lever, okay, it, has to move at a speed that's twice the speed that this moved at. And if it's moving at twice this, obviously that's only, if this moves at half the speed, that means that the energy the lever's consuming is less as a percentage. So I went to the whole point and pointed out how this is 1/3 and this is 2/5 or whatever, ratios and all that stuff I think is important. And the bottom line was is the way to do the experiment is to compensate for that, the problem of the lever disproportionately, okay, consuming, being a higher percentage, the mass of the lever being a higher percentage of the mass being moved, okay, the lighter the object is. And the way you compensate for that is just to put the lighter mass out here further, okay, to get a higher velocity. And then you can have the correct ratio. But nobody wanted to do that experiment. So they were satisfied to get their imperfect results and go no further. And then Despard did car experiments. All right, and I pointed out some obvious flaws in the experimental approach, but again, he didn't really want to hear about any of that. That there might be variables he's not accounting for. And in the last case, we had a kind of a simple idea. Okay, got rid of a lot of the other problems. Had a nice little quick release, just a simple rubber band, and you're just going to push a car. Now, the problem in this case was piling the masses on the car. So what you end up with is you're comparing two cars, one with 4 wheels, okay, for the amount of mass. And then the other one you're going to pile on twice as much on the same 4 wheels. Alright, so if you could argue that the wheels are a source of a problem in the sense that at higher speed they have more angular momentum. So the higher the speed, the more energy ends up being stuck rotating the wheels and whatever friction the wheels are causing. So you end up with the friction of the wheels plus the angular momentum of the wheels will take away from the size of this velocity arrow. So the velocity arrow gets limited by the energy that has to go into the wheels. Now when you double up on the mass, you still only have 4 wheels, and your angular momentum is less because they're rotating at 1/2 the speed. So you have half the angular momentum problem, and presumably because you only have 4 wheels per unit of mass, where you have now twice as many units of mass per wheel, you're losing less energy to the wheels than you are losing to the mass. So the carts you end up with a better velocity than you did in the first case. You're losing more to the wheels, okay, and you're losing less to the wheels because there's fewer of them and they have less angular momentum. So you're able to have a higher velocity for the heavier cart than if you had an ideal circumstance where there was no friction and no angular momentum, but there is. So I made the simple suggestion first. He does the experiment at very high velocities, which makes it really hard to analyze anything, and to it certainly does stress the system, where you can understand the cart might not leave, it might lift up, it might change its trajectory, it might do a lot of things. So he should just lower the velocity of the experiment. And also I pointed out that it might be a fairer comparison just to put 2 cars instead of piling the mass on top of the other car. Then there's the same number of wheels per unit of mass, so the mass to wheel ratio is the same, that would be a better test, but unwilling to do that. Okay, so he wasn't willing to make those modifications, and so they moved on to a coupled oscillator. Pointed out things to avoid anyway. So I described a rather simple experiment. You guys have 2 pendulums. I pointed out how it is rather important, okay, you have 2 to 1 mass, that they be the same length, obviously. And the idea is to create a coupled oscillator. That is, one object will swing, and what it'll do is slowly but surely give its energy to the other object. And so then all the energy will be in one object, the other object will be still, then this one will go with all the movement, and this one will go still. Now, I suggested a loose connection between the 2, and instead he did a very tight connection between the 2. I'd say so tight that he was even creating, perhaps, we didn't get to see all this because he provided a 2-minute edited video instead of showing us actually how the experiment was set up, whether these were actually the same length. All of those details were not provided, how the pendulums were attached to whatever they were attached to originally. So he created a more rigid elastic between the 2, tying them essentially to each other with tension constantly. So instead of having a straight pendulum, which would have a bottom here, he has a canted pendulum, okay, with a bottom that's much higher in gravitational potential. So now you can understand, perhaps, that when this starts swinging, there'll be times when this band moves in this direction. When it moves in this direction, the pendulum gets actually longer, okay, which increases the velocity. And as it gets shorter, it decreases the velocity, okay, because it's put more energy back into gravity. So at any one point, when it stops here, swings and it stops, you know that it still has its energy, so to speak, in the sense that now it's in the form of the gravitational capacity to fall, the free fall height. And now it has the capacity to drop to the bottom of the arc. So that's where the energy is stored. and there's the peak point where there's now at the bottom, the lowest point they can reach in gravity, at the bottom of the curve, is where the energy in the velocity is at the peak, and the energy in the potential is at zero. And so that was the place he wanted to measure. Now the problem is if this is in fact changing the shape of this pendulum, that means you're changing its length. That means the bottom and that you're reading might be a different location. So one might be swinging above this arc, and one might be swinging below the arc, and obviously the one below will read a higher velocity than the one above, because more energy will be stored in the fact that it has gravitational potential, that it has pushed the object up, or the object has remained up, and that's where the energy is. So it can't be in the form of its velocity, because it's still stored in the fact that it hasn't reached the starting bottom. And these are all details. They're and they just happen to be facts. Fact is, it's not that simple. Okay, and so if you have a complication, then you're going to have to deal with that complication. And he didn't want to hear about that. He also has objects that are of different size, which isn't ideal. Going through a timing gate, little subtle problems that you could argue could matter. Even the location of the timing gate, as pointed out, the timing gate has a bias, in the sense that if you're going to push something through it, the image side, the side that's the eyeball, the further away you are from the eyeball, the smaller your object that you're passing through gets. So if I pass this pen through this field out here, from my perspective it's small and narrow. From your perspective it's fat and thick. And so you can sort of understand that the closer I am to the eye, when I pass whatever the object is I'm going to pass, its size changes. And so you do have to be aware of that and try to mitigate against it, in the sense of allow things to pass through better. So anyway, so there's lots of reasons to understand that there's tugging going on if you have these pendulums too rigidly coupled. And the idea is to make the couple as weak and as unperverting as possible. That is, that the coupling is so subtle that it never changes the pitch of this pendulum, that it just allows the pendulum to pull on it. The string pulls a little bit, but it doesn't create a change in the arc, a substantial one anyway. You want to make that as unsubstantial as possible. You want to minimize it. Maybe you can't eliminate, but you can minimize it as an effect. So anyway, he is apparently unwilling to make any of these modifications to take care of any of these concerns, and is satisfied that he has once again, in a 2-minute edited video, proven that momentum isn't conserved, which is really the whole argument here. The other experiments do have to do with kinetic impact, and those weren't very well done either. Okay, and we've already been over this idea, dozens of times. But this idea that somehow you could put energy in of 100 momentum, that you next phase of the experiment, guess I could draw that better. The next phase of the experiment, okay, you have a total of 150 and 50 in terms of movement of mass in the universe. So you've doubled your momentum to 200 total, and then when they come back and collide again, you end up back at where you were, which is you have one object with 100. It's going to be 98 or whatever, some smaller number. But this very idea that you could have a car crash between something with 150 momentums and a thing with 50 momentums, and they could have a head-on collision, and you could only have 100 pop out. that should be understood to be kind of a non-starter. That never happens in reality. You can never cancel this 50 and cancel this 50 and only get 100 out of the crash. I mean, whether I'm banging two sticks of dynamite into each other just doesn't matter what they are. I can't undo one thing's motion, okay, by having an opposite motion. So you can't take two elastic objects, that is, objects that aren't going to deform or bend or twist or do something stupid, use the energy in some other way. You can't take two hard objects and ever collide them and they stop, okay, and nothing happened. Right? If I stop two kinetic balls that crash into each other and I force them to stay in contact, then I'll get a great deal of heat, okay, here. All right, enough to burn paper, even melt foil. So we know it's not just going from 100 here and 100 here into 0 somehow. There is no canceling, there is no 0. What there's going to be is 200 watts, so to speak, of energy, 200 hunks of it in the center of this crash. That's what's going to be here, all right, is that much potential pushing power when 100 hits 100. Now, if 100 hits, nothing, something that's not moving, then all you have is the 100, okay, and that's all you have. But yeah, if the two are both moving, right in between the two is going to be an explosion that has the 200. No doubt about it. Well, apparently there is some doubt about it. I'm just saying from my perspective, there's a little doubt about how those collisions work, how pool tables work, that the momentum is conserved, and you can't make more momentum and then destroy the momentum. Can't do it. So if you have an experiment that's showing that, there's probably a catch somewhere in what you're doing. Okay, that's the explanation for the fact that you didn't find that momentum is conserved. But they really don't want to hear that. So anyway, so the bottom line is obviously they won't do these experiments correctly. They'll do them to their own satisfaction. And they've clearly demonstrated that they'll only publish them when the results come out their way. So when the results don't come out the way they think they should come out, they don't publish. When they come out the way they want them to, when they've engineered it to come out their way, then they publish it and kind of imply that it never came out any other way. That no, they never found anything else happen. I mean, I have to wonder why in every one of Dispar's experiments he's either got things going really fast or, there's always a catch. And in the case of the coupled oscillator, I described it. I mean, I went to the trouble to explain how, I left it loose and I just put a tiny little weight on it and just that tiny little weight. And, I went through the whole thing of talking about how, and almost saying, well, why would he then, make this tighter and tighter? Why, instead of making it looser and looser, why wouldn't he try to get it to work as a, without distorting the length of these pendulums? And the answer is because, that's not going to come out his way. So if he does the experiment right, it's not going to come out his way. That's the simple answer. So when he says he can't do it or it didn't work, what didn't work means it didn't come out his way. It didn't mean it didn't work. It just means the results aren't what he wants them to look like. And that's what, the history of this science proves. That's all that this is about, is propagandizing. And I could be guilty of it too. But the Chardonnay did it. These are all engineered experiments. Experiments engineered to show something. And it's not engineered to show you how it mechanically works. It's engineered to propagandize or provide an implication that you have a match when you don't really have a match. That kind of thing. It's to cheat the truth, not to find the truth. So, I think that's enough But you can see it in everything. I mean, the unredone Eddington experiment, 400 times better resolution from space. You don't need an eclipse. It takes 5 minutes to do. You could even use Jupiter, and they still haven't done the experiment. And the excuse is, well, we proved it other ways. Well, what does that have to do with anything? The other ways aren't this way. This way is the way where you can actually see it. It's very clear, and it's very obvious that it can't be some other cause. So if you get the result, it's a very secure result, where these other experiments have a lot of variables that are that create uncertainty and make it less credible. The simpler you can make the experiment, the better. Again, it was good that he went to just a plain rubber band. I mean, it's good that Gosling cut it down to pretty simple mechanics. I'm just going to drop a weight and get it as flat as I can and smush something with it. And, it's, yeah, that's what should be done. But where has the history of physics shown any of that? So where have they shown it taking 4 times the fuel to go twice as fast? Or where have they shown something going 4 times as fast doing 16 times the damage? Where have they ever shown an 8-pound bowling ball going twice the speed of a 16-pound ball, knocking down twice as many pins? Never. And, that's glaring. Those facts are glaring. The absence of evidence is glaring. And it's disingenuous that these advocates won't concede that fact, because it just makes them into suspect. It just makes them incredible. I mean, you lose credibility if you're not willing to admit these experiments should have already been done by physics, and they should have been done well. You don't have any credibility. You just said you're basically just looking for excuses and lies to propagandize for your side, because you're against the evidence essentially. If you don't advocate for the creation of good experimental evidence. So again, this Barr character thinks he's going to prove the theory that momentum isn't conserved in perfectly elastic experiments, in contradiction, frankly, to stated physics, well-established physics, with a 2-minute video, with a handheld camera. No, I don't think so. So anyway, probably enough of a video, but there's always, like I said, unfortunately, if this was simple, then maybe it would have been done by some amateur by now. But the fact is that none of these experiments can be just slopped together. They have to go through this thought process of what is the nature, the difference between a mechanical release and a quick release. You have to understand these differences. It's not just about disconnecting you from the system. It's about creating a mechanism that doesn't add or subtract from the experiment, that leaves the experiment alone, so you can see the experiment do what it does without it being distorted or affected, because your start button isn't quick enough. Anyway, alright, so till the next time and such and so forth. And whatnot, I think that's enough. Oh yeah, well, I was going to read, I guess, the Dispar comments. I mean, just because he's just demonstrating, I mean, that, he doesn't want to take any responsibility for the boldness of his assertion. Alright, so again, this was the clip. Okay, you get nothing here. This is all you get visually of how these pendulums are hanging. You can't even see the coupling device. These two velocity measuring things don't exactly look perfectly aligned. Lots of reasons to doubt. Okay, and this is what he says. I consider proving the 1.4 thing to be absolutely done by now. So these crappy experiments, all having some or other kind of flaws in them, and he says this is good enough. So whatever. It doesn't matter what kind of experiment we set up. So again, he says we. Whatever. And again, you can't follow you can't argue any of the physics. So I just pointed out something about the cars and angular momentum and the fact that you have different mass to wheel ratios. I point out all this stuff. You don't argue any of it. You don't defend yourself against these accusations that you were shooting your cars unnecessarily fast. I mean, way in excess of what's necessary to see the experiment. Why the fuck did you do that? Exactly. You never tried it slower? Is that what you're telling me? You never even occurred to you to move the cars, 1/10 of that speed? Just fast enough to do the experiment? Why would you do it faster than necessary when slower is so much easier to see? I mean, you're just such a pile of shit anyway. The one mass just never will go twice as fast. So, again, not consistent with my own results, but besides that, even without that, this is junk science. Okay, so Walker and his phantasmagorical crap, and when applied to my results, blah, 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 blah. He's just, it wouldn't apply to your results. The results you said where, you couldn't even, he said it was impossible to make two things, the same shape, that weigh the same. And I had showed this already in my video. It's just a hollow object. You can put different weights inside of it. You have the same profile for your two objects. And I pointed out you could use medicine bottles, lots of things. Lots of ways to figure it out if you thought about it. But he just decided to say it's impossible. All right, let's see. Exactly, I have done various experiments by now. Okay. And all of them coincidentally. So yeah, there's no coincidence. Again, what's the coincidence in the fact that we can't even view Ian Gosling's experiment? You think it's a coincidence that the only experiment that he didn't show is the one that came out my way? It's just a coincidence that it worked out that way? No, it's no coincidence. The fact that you just post experiments where you show us none of the preliminary work. You don't show us, playing with it yourself and saying, well, I set it up this way, this is what it does. And I set it up this way, this is what it does. Did you do any of that? No. With the lever experiments or anything else, did you try different distances? No. You didn't try anything. At least that's what you imply, that you tried nothing else. You just did it one way, and that's the only way you ever did it. And I'm supposed to believe that you just coincidentally each time did it in some way that contrived your results. Yeah, I don't think so. All right, approach the 1.4 and never 1.6, let alone 1.8 or 2. It's amazing how he keeps saying that the evidence is still indecisive. Your credibility is indecisive, okay? is unproven, all right, and is suspect. So, and certainly Ian Gosling's will remain that way forever until he mans up and actually redoes the clay experiment and shows us what he saw, and then has to explain that experiment, explain why it didn't come out his way. All right. Sorry about his response this far. So my response was just to point out some what I thought were obvious defects. Okay, I know what it feels like when you have put time and effort. So this is, they complain, and then when you look at these experiments, you're saying, look how simple this all is, in a sense. They're pretty crude experiments. And once they have the setup, why don't you do the variations? You have it all set up, and then that's where they stop. They just stop. So he had the car thing, and they stopped doing it. They had the lever thing. They just stopped doing it. It has carbon fiber for a lever. Stop doing experiments. Stop doing variations. Why? Oh, that's right, because he accomplished his task, which is to create the propaganda and to deceive everybody into thinking no other results are possible. The experiment always comes out the same way, no matter what he does. Okay? But the what he does is bullshit. You say things like, well, why don't you make the pendulums longer? Why don't you do this? Why? No, he doesn't try any of that shit. It's so dishonest. All right. Put time and effort in doing these experiments, and then it's insinuated that you have cheated. Well, didn't you cheat overtly? You didn't show an experiment that was decisively against your theory, and you're calling that not cheating. Didn't you cheat the evidence pool by saying we're going to exclude the experiment that came out his way? We're going to push and promote our experiments, but we're going to hide that one. Isn't that, if that's not cheating, what the fuck is it, fuckhead? You cheated by not videoing it. Just honestly say to me, you wouldn't have videoed it if it came out exactly your way. So if it came out confirming your theory, tell me honestly that you wouldn't have videotaped it and put it up on YouTube. Go ahead, tell me that. And just show what a big fucking liar you are. So you're just pretending that you people are, your credibility isn't above critique or suspect. It's just such bullshit when you're so overtly dishonest. All right. Well done for truth seeking. So they're seeking the truth, okay? And the truth is, Gosling guy thinks that regular physicists think the kinetic energy in the car, the train, 10-ton train, 5-ton train scenario, that the kinetic energy just somehow vaporizes into the ether somewhere, that it disappears. When every single physicist who talks about that experiment uses words like deformation, heat, sound, vibrations, they all blame the loss of kinetic energy on some sort of escaping energy. All right. And that's where I've got them, because obviously Gosling's smart enough to know that now you need momentum to make something else move. So you really can't do it with nothing. You have to use something's momentum. Bowling balls lose their momentum when pins fly. Pins can't fly if the ball keeps its momentum. He knows that's true. Ian, there are only two possibilities. It's done badly or it's manipulated, but him being wrong. What the hell is this? No. If it doesn't make sense to him, it can't be reality. So that is partially true. I mean, I'm just saying that the whole argument is to make something make sense. So you're saying you have this piece of evidence that, again, I can't critique. So at a trial, if somebody shows up and they says, well, I looked at the blood and it looks like it's B positive. Yeah, no, I didn't bother using a microscope or anything. It looks like B positive blood. I'm supposed to take that too. How seriously do I take it? So I'm just saying that obviously your experiments are rickety, and I have good reason, okay, to doubt them. All right. Because you didn't consider all these variables. You don't consider them, and you won't try the experiment in the alternative ways. So the very fact that you refuse to do the alternative experiments, the modifications, play with the experiment, do it in a lot of variety of ways, just demonstrates that you just want to create the outcome and publish it as a 2-minute video. All right, I think this is the end of the argument. Well, it won't be. Okay, as stated, look, eventually I'm going to have to do these experiments. Okay, I don't want to, but that's the way it's going to have to be. All right, and I'll show the variations, and I'll show outcomes that are going to be dramatically different from theirs. All right, it should be. Well, once again, he called it indecisive evidence. I called it a shit experiment, frankly. I can see nothing. Okay, you showed absolutely nothing in the video, frankly. Okay, about anything being precise. You didn't even, frankly, you didn't even show us if the pendulums hang at the same length. You didn't show us the center of mass. I mean, you have them tied, they're different sizes. Is the center of mass in the same location? Did you do any of that shit? No. Will the velocities be the same if you don't have the same length of pendulum? No. They won't be comparable. The longer pendulum is going to have a higher velocity. Fuckhead. Well, it's going to have a higher velocity if you're changing its arc. So if the arc is getting changed because you're changing the straightness of the pendulum, then you're going to change the velocity. All right. Because you're going to be going up or down in gravity, and more or less of the energy is going to be stuck in the gravitational potential instead of being in its velocity. But whatever, I shouldn't have to explain all that. I guess I should hit the sort button just for the hell of it. Alright, nothing. Somebody is in here somewhere, I guess. Oh, it's more Walker crap. Okay. Totally ignorable. So mindless marvels. In my understanding, no single experiment directly proves or disproves anything. Well, I don't think that's true. I mean, I think you can do experiments that are so simple that the outcome is non-negotiable, as Professor Lewin would say. But you always have to be careful. I mean, obviously, Professor Lewin says that, the double slit experiment is nail in the coffin evidence of wave theory. Well, I don't think so. Anyway, I understand this is counter to my popular narratives. I don't know what that is. However, at this point, we have an accumulation of evidence against DraftScience idea that overwhelmingly support that he is wrong. So again, even though all the space stuff, I win decisively, with all the theoretical arguments I've won decisively, all right, they still don't have any explanations for how momentum can be poofed into existence, how two cars, one going 150 miles an hour and one going 50 miles an hour, could only create 100 miles an hour of total energy out. How is that possible in this physical universe? So bullshit on you, mindless. Anyway. So we'll see where it goes. Blah, 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 blah. Blah, blah. So, till the next time and such. And so forth and whatnot. Now I have a toothache. Yeah. It's really been a bad string of days.